As a geek and someone who has worked in information technology for over 25 years, when I find a cool technology solution, I like to share my findings and experiences with other geeks. I've used RAID arrays for nearly my entire career, which are redundant arrays of independent disks. This is where you configure multiple hard drives in an array to provide for enhanced capacity, speed, redundancy, or all of the above. Traditionally speaking, there were multiple ways to configure your RAID arrays depending on what you're trying to accomplish. I'm not going to cover them all because this can get very long and technical, but the common RAID configurations have traditionally been RAID 0, which uses data striping across all disks, which provides greater capacity and speeds up data access, but provides no redundancy. So if one disk fails, all data is lost. RAID 1 provides data mirroring, but no striping, so the capacity is that of half of the disks. But if a disk fails, no data is lost, and the bad hard drive can be replaced and the data will be rebuilt. RAID 5 uses block-level striping with distributed parity and requires at least 3 disks. The data and the information about the data, or parity, is spread among all the disks in such a manner that a single drive failure will not result in loss of data, though the array will run in a reduced performance state until the bad drive is replaced and the array is repaired. RAID 6 uses block-level striping with double distributed parity and requires at least 4 disks. This means that it can sustain a failure of up to 2 drives, and it's less susceptible to total data loss when repairing after a drive loss using RAID 5. RAID 10 is actually a combination of RAID 1 and RAID 0 used together to create a striped set from a series of mirrored drives, resulting in higher performance and redundancy, but typically using more disks to accomplish it. Sometimes you will find servers running their operating systems in an internal quote-unquote RAID 1 or RAID 5 array where drives are installed in their server chassis. You will usually find larger arrays, however, in a SAN or storage area network, or a NAS or network attached storage. A SAN is essentially a large RAID controller in which you place drives, and then the SAN is attached to a server or cluster of servers via one of 3 methods: fiber channel, iSCSI, or InfiniBand. Some solutions, such as a Dell Vertex or Cisco UCS and many others, essentially combine storage and server blades into a single chassis system as well. A NAS, on the other hand, is a separate storage array chassis that is connected to the network and not directly to a server. Over the years, I've personally preferred SANs because of performance, and they've been easier to integrate and manage in terms of permissions, but that's changing. While I have engineered and managed some large and complex enterprise solutions in my professional career, like most geeks, I also like to explore and utilize technology in my personal life as well. I've been running Windows Server at home for Active Directory functionality, including authentication, file and print services, DNS, and DHCP since 2008, starting with Windows Server 2008, and moving on to Server 2012, and then Server 2016, and now Server 2019. In the same time period, I have also been running a Drobo, starting out with Generation 1, and then moving to a Generation 2, and finally a Generation 3 Drobo. The Drobo was created by Data Robotics and was a bit of a revolutionary storage appliance in that you could add SATA drives, rather than SCSI drives, one by one to the device. You could use off-the-shelf consumer drives to create your own large storage array, even mixing and matching drive sizes and brands, something that was traditionally forbidden in the RAID world. The Drobo would manage the drive array for you, making the most of available space and providing you with the most redundancy available based on the number and size of the drives you fed it. It accomplished this with an onboard computer running Linux in a system the Drobo called Beyond RAID. While I experienced some hiccups in the early models, by the 3rd generation they had most of the bugs worked out and they worked quite reliably and were decently fast for what they were doing. The Drobo was always attached to my Windows Server via USB, and this allowed me to manage file permissions via NTFS. Today, Drobo makes NAS solutions as well, but I don't have any personal experience with those. I started looking at other products to see what was on the market and became interested to discover that the Synology NAS, a Drobo competitor, allows you to join a Windows domain and enforce NTFS access permissions on its shares. The Synology also has a management mode called SHR, or Synology Hybrid RAID, which is very similar to the Beyond RAID technology that Drobo uses. It essentially designs your RAID based on the drives that you give it to work with. I ended up purchasing a Synology DS1019 Plus and added 4 8TB drives and set it up with SHR, which essentially sets that up as a RAID 5 array. Do keep in mind that building that array or adding a drive to it can take several days for the data to organize itself properly. This is not the fault of the Synology, just a function of what SHR and RAID is doing, and it's very time consuming. I did find that enabling write caching on the drives helps the process along quite a bit, but only do this if you have a UPS providing backup power and notifying the Synology to shut down in the event the UPS is running low on battery power. Synology makes this process pretty slick via USB cable and most modern UPSs. I'll even get an email from the Synology when there's a power blip and the UPS is running on battery power. The Synology is managed primarily via a web interface, but can also be accessed via SSH. The Synology runs a proprietary Linux-based OS called DSM, or Disk Station Manager, which is actually pretty well written. The web interface presents a desktop, very similar to Windows or Android, and there's a package center through which you can install a myriad of packages which dramatically expand the capabilities of the Synology. Some of the packages that I use include Snapshot Replication, which allows the previous version functionality whereby you can roll back file and folder changes en masse in the event of something like a ransomware infection, where you have mass files encrypted or otherwise lost, or just a single file that somebody accidentally deleted or lost. Cloud Sync is a package that syncs specified data with a cloud provider such as Amazon S3 or Google Drive, for example. Docker is a platform for many small containerized apps and will run on the Synology. One of the Docker apps that I run is the Ubiquiti Unify controller to manage my Ubiquiti wireless access points and firewall. Plex is another popular package which serves up our family home media collection, including transcoding video when required. Virtual Machine Manager, in which I can actually spin up full-blown virtual machines, including my Windows 2019 server should the need arise, such as in a backup situation if my primary server goes down. The Synology isn't quite as powerful as most servers, but it's still pretty capable with 8 gigs of DDR3L RAM and an Intel quad-core 1.5 GHz processor capable of bursting to 2.3 GHz. I also use the Office 365 data backup package, and it even includes a built-in antivirus package. The Synology model that I have has 2 gigabit Ethernet ports, and I was able to bond these two ports together, allowing up to 2 gigabits per second of network performance. I map the Synology SMB shares to my domain computers via group policy, but there are many other ways to access data on your NAS, including mobile apps, FTP, TFTP, rsync, and even Bonjour for those odd Apple users. There are a number of advanced features that I don't utilize at this time, but some of them include the ability to add a module to expand drive bays, the ability to replicate data with other Synology NAS units, the ability to create a high availability Synology NAS cluster. In addition to running a server VM, you can run a number of servers on the Synology natively, including LDAP, DNS, Media, Mail, VPN, Web, WebDAV, WordPress, vTiger, Ruby, PHP, SSO, Radius, and many, many others. If you're considering a NAS or a SAN, that likely means you have a lot of data to manage. Presuming that data is important to you, not only do you want redundancy in place in the event of a hard drive failure, but you'll want to ensure that you have multiple backups in place for that data. Personally, in addition to the redundant NAS, I have a physical backup in a Faraday cage, as well as offsite backups on multiple cloud providers, one going to Amazon S3, Glacier, using traditional versioned backups, and the other being a real-time sync with Google Drive, which also supports versioning and deletion protection. I would strongly recommend that you consider multiple backups for any data that you deem critical. The Synology makes those data backups and syncs very easy with the built-in packages. In a nutshell, so far, I've been very impressed with the capabilities of the Synology DS1019 Plus. The Drobos that I had experience with were simpler, so if you don't need the advanced features, that might be easier for someone to manage if they aren't technical in nature, but if you're technically inclined, the Synology offers many features and capabilities that actually put it in a class where it's not just a NAS, but also a small server platform. QNAP is another brand that I don't have any experience with in this market, but I also hear make good NAS options. I hope you found this review helpful. Overall, I definitely recommend the Synology NAS devices. Please like, subscribe, and click the bell. And don't forget to tell us in the comments below what you think of this review, or what you think of this NAS if you own one. If you decide to purchase this NAS, please use the Amazon link below. Thanks.